Okay, in this video, we are going to solve more problems related to constructing regular expressions. So once we are given with a language, a regular language, we'll be able to create an equivalent regular expression for that language. So we'll be exploring more problems in this video. Now, before actually moving in for solving the problems, let's revisit something which we have already seen in one of our earlier videos. So remember that if you're given with a regular language, okay, so hope you are very much aware about the differences between a regular language and a non-regular language. We have seen plenty of examples, which are languages which are regular and which are not regular. And if you're given with a regular language, it can be accepted by an FA. Okay, so you can actually construct different kinds of FAs for accepting a regular language. Remember that you cannot create an FA for accepting a non-regular language. Again, an FA can be a DFA, an NFA, or an epsilon NFA. Okay, so if you're given with a regular language, you can actually create one of these to accept that particular language. And remember, one of the typical examples of a language which is non-regular is a raised to n, b raised to n. That's a raised to n, b raised to n, where n is greater than or equal to 1. Okay, here we want to make sure that the language contains equal number of A's and B's, in the sense, and also B, after seeing n A's, you should exactly see n B's. Okay, so this is a very typical example of a non-regular language. For this particular language, we cannot create an FA just because this is a non-regular language. Now, if you look at this example, AB raised to n, where n is greater than or equal to 1. So this means that you should see continuous patterns of ABs. Okay, so your possible string can be an AB or AB, or an AB. So this doesn't require you to count the number of A's and number of B's. So this particular language can be is a regular language. This is a regular language, whereas this A raised to n, B raised to n is a non-regular language. It's very important. Okay, so you cannot actually design since this is a non-regular language. You cannot actually design an NFA or a DFA or an epsilon NFA for that. But whereas this language here, AB whole raised to n, is a regular language, and therefore we can create NFAs, DFAs, or epsilon NFAs for representing the same. Now, a regular expression is again used to represent a regular language. Okay, so a regular expression is used to represent a regular language. So you cannot use a regular expression to represent a non-regular language. Okay, so it means that if you're given with a regular expression, you actually have created it because you are converting it, you are representing a regular language. Okay, and similarly, if you're given with a regular expression, you can actually convert it into an FA. And similarly, if you're given with an FA, you can convert it back to a regular expression. So given a language, so if it is very important to note that given a regular language, you can actually represent it always using a regular expression. Okay, so if the language is non-regular, you cannot use a regular expression to represent it. Okay, in the name itself, it is there. So regular languages can only be represented using a regular expression. Okay, so if you are given with this language, that is A raised to n, B raised to n, where n is greater than or equal to 1, and if you're asked to write its regular expression, you cannot actually do that because it's a non-regular language. Okay, so you can only write regular expressions for regular languages. And also, it's very important to note that if you have a regular expression with you, you can actually convert it into any of this because DFAs, NFAs, or epsilon NFAs. And given a DFA or an NFA, you can actually convert it to a regular expression as well. Okay, so these two conversions are possible. You can actually convert a regular expression to an FA, and similarly, an FA can be converted back to a regular expression. So these are the three things that we are going to look at generally in this particular unit. So the first, we'll start creating. If we are given with a regular language, we can create its equivalent regular expressions. Okay, the regular language can be described in words or given as a set notation. Okay, and the next thing is that given a regular language, you should be able to given a regular expression, we will be able to convert it into an FA. And similarly, the third thing that we are looking at is given an FA. So FA can be DFA, NFA, or epsilon NFA. Given an FA, you can actually convert it into a regular expression. Okay, so these are the things that we are going to look at. Remember, given a regular language, you can actually convert it into a regular expression. Okay, so by looking at the regular expression, we can actually get to know the properties of that language. Okay, so there are actually standard ways of converting a regular expression to an FA and an FA to a regular expression. Don't worry about these things now. We'll get to know each of these later. So in this video, we'll be focusing on solving more problems. So in this part, we are given with a regular language in the form of a description or in the form of a set notation. So we are interested in converting those regular languages to regular expressions. So it again requires some sort of an intuition. There are no standard ways of converting a regular language to a regular expression. So you should look at different ways of converting it. And also, very importantly, remember that given a regular language, you can create multiple regular expressions, which will again represent the regular language. Okay, so it is not that there is only one regular expression for a regular language. It's not so. You can actually, it's the same with the case of FAs. We have already seen that for a given regular language, and a DFA can be drawn in different ways. Okay, there is nothing unique about a DFA. So given a regular language, you can draw multiple DFAs to accept the same. So this is also applicable for regular languages. So if you're given with the regular languages, you can actually come up with different regular expressions, all of them holding the same. Okay, so all of them can represent that regular language. It's possible. Okay, so we should look at the ways of representing. Given a regular language, we should be able to represent it as a valid regular expression. Okay, as a valid regular expression. Okay, so it is something which is very similar to converting regular languages to FAs, but at this stage we are converting regular languages to regular expressions. Okay. Now, I forgot to mention one important thing here. So there can be something called like grammar, which one of the grammars is called regular grammars. Okay, so regular grammars can actually generate regular languages. Okay, so if a regular language is generated by a regular grammar, a regular language can be accepted by an FA, and regular language can be represented by a regular expression. So these are very important. Remember, there is a general term called grammar. Okay, so regular grammar is a subdivision of your grammar itself. So when you look at a grammar can be used to represent. A grammar can generate both regular and non-regular languages. It's possible for a grammar to generate both regular and non-regular languages. For example, if you look at this example of a raised to n, b raised to n, so that I can write a grammar. I can write a grammar to generate this language. It's possible, but that will not be a regular grammar. Okay, so remember, a regular grammar always generates a regular language. Okay, a regular grammar always generates a regular language. And remember, when you say generally a grammar, okay, remember that regular grammar is a subdivision of your grammar. And grammar in general, grammar can generate both regular languages and non-regular languages. Okay, so I just wanted to give you just an idea of what is a grammar and what is a regular grammar. Okay. Okay, now let's go through these problems. So in all these problems, we have to construct a regular expression based on the description given. Okay, so in this problem, we are asked to, in the first problem, we are asked to construct a regular expression to represent the strings that contain the substring 0, 1, 0. Okay, so where the alphabet set is 0, 1. So it is only mandatory that the strings should contain 0, 1, 0 as a substring. Okay, so how can we approach this problem? So there is no restriction on, you should start with 0, 1, 0 or end with 0, 1, 0, or you should exactly see 0, 1, 0 in the middle. There are no such restrictions. The only restriction is that the string should contain at least one occurrence of 0, 1, 0. Okay, so it means that, essentially means that you can see anything in the beginning. Okay, that is 0 or 1 any number of times or not even once. And then you can see 0, 1, 0, and then followed by anything else, 0 plus 1 star. So this would be the answer. Here, note that the star operator tells you that this pattern can repeat 0 or more times. 0 or more. Similarly, this also is meaning 0 or more. So in the sense, if you are given with just the string 0, 1, 0 as your input, this will be accepted, where now the star notation takes the meaning 0. Okay, 0, 1, 0 will be accepted, 0, 0, 1, 1, 0, 1, 0. This will be accepted, followed by anything. Okay, so this will be accepted because there is a 0, 1, 0 here. So you can put all the strings having 0, 1, 0 as a substring, and then you can make sure that this regular expression will represent that particular string. Okay. Now let's look at this question. So here we want to create construct a regular expression which will represent all the strings that ends in 1001. Okay, so it's clearly mentioned that it should end in 1001. So it's going to be very trivial. It's very similar to the construction of an NFA. So you can see anything in the beginning, 0 plus 1 star. Okay, so, and it should end with 1001. 1001. Okay, so so this is how we can create a regular expression to accept all the strings that ends in 1001. Okay, now let's look at this question. So here we want to construct a regular expression to represent strings that start and end in 1. Okay, this is slightly tricky one. So we should have strings such that it should start and end in 1. So the minimum string that starts and ends in 1 is just 1. Okay, this the string 1 must be accepted because it starts and ends in 1. Similarly, if you look at this 1001, this also starts and ends in 1. Similarly, 1111, this also has to be accepted. So all these varieties of strings has to be accepted, right? So our regular expression should be constructed in such a way. So let's look at how we can create this. So if I'm saying I have something like this, I am having a 1, so that it starts with 1, and I can see anything in between, that is 0 plus 1 star. Okay, again, one more thing to note here is that 1, 1 has also to be accepted here, because this string also starts and ends with 1. Okay, so I can see, so I'm looking at the regular expression. Okay, so if I write like this, 1 followed by 0 plus 1 star followed by 1. Okay, this will accept everything like 1, 1, and 1, and anything in between, and finally which will end with 1. Okay, so all these things will be accepted. What about just a 1? Okay, so if you look at this, okay, so if whether this regular expression is able to represent the string 1, just 1. So it is not able to, because the minimum string it can produce, the minimum string it can represent is 1 1. Okay, so 1 1 is the minimum string which can be represented by this regular expression. So what can we do about it? So we just add plus. Okay, we are saying or 1. Okay, so I can put a bracket for more clarity here. So I can write it like this. Okay, 1 followed by 0 plus 1 star followed by 1, or this plus represents an or operation, or 1 itself. Okay, now this regular expression is able to represent 1 also. Okay. Now let us look at this question. Okay, the strings that starts and ends, in same symbol. So here the symbol is not mentioned. It can be a 1 or a 0. Okay, so here what we have to do is that we have to accommodate all the strings that starts and end in 1 as well as strings that starts and end in 0. So now this becomes very trivial for us. So it's going to be, I can represent it easily by saying 1 here. These are the strings which will start and end with 1. Okay, plus 1 plus, again, you can have, these are the strings, so 0 plus 1 star, 0 plus 0. Okay, so you can identify that this particular portion will represent all the strings that starts and ends in 1, and this particular portion represent the strings that starts and ends in 0. So combining this by using an OR operator here, you will get both. So this big regular expression would represent all the strings that starts and ends with the same symbol. So this is going to be straightforward. Now, this is another interesting question where we are asked to create a regular expression which will represent the binary strings that starts and ends in different symbols. Okay, so it means that you can, if the string begins with a 0, you can see anything followed by that, and it should end with a 1. Similarly, if the string starts with a 1, you can see anything, but at the end you should see a 0. Okay, so when you look at this problem, the minimum strings possible are 0, 1. So there is nothing in between. Similarly, 1, 0. Okay, see, these are the minimum strings that your regular expression should be able to represent, right? So how can we write this? So it's going to be very easy. So so I'm going to write the regular expression for this. So I'm starting with a 0. That means I can see anything in between. So when I put a star, I mean that this pattern can repeat even 0 times as well. Okay, then I can put a 1 here. That means 0, 1 will be accepted. So we have one more pattern which starts with 1. So just put a plus to mean or, to mean an or operation here. And then okay, and then what you can do here is that you can have a starting with 1, then you can see anything, and then ending with 0. Okay, so this would represent all the strings that starts and ends with different symbols. Remember, our alphabet set contains only 0 and 1. Now we'll move to the next question. So here we have to represent, create a regular expression which will represent the string where the fourth symbol from the left is a 1. Okay, so if you look at this string, you can see that this is your first symbol, this is your second symbol, third symbol, and fourth symbol. Okay, so you can see that the fourth symbol from the left is a 1. So all these kinds of strings has to be accepted. Okay, so that means, so the initial symbol can be anything. It can be a 0 plus 1. The second symbol can be anything. Again, it can be 0 plus 1. Third symbol, there is no restriction. It can be 0 or 1, I should say. And then the fourth symbol, there's a restriction. Okay, the fourth symbol from the left has to be 1. So I have to put a 1 here. And then it can be followed by anything. Okay, so anything, any number of times. So that's why we will be able to write 0 plus 1 star, right? So again, this can be the representation can be made shorter by saying 0 plus 1 3 times. Okay, so remember, this is going to mean that you can repeat 0 or 1 3 times, then followed by a 1, and then followed by 0 or a 1, that is star, because you can see it 0 or more times. So this is the short way of representing languages with fourth symbol from the left as well. Now this question is a variation of the previous question. Here we are asked to construct a regular expression to represent a language where fourth symbol from the right is 0. So we are asked to look at fourth symbol from the right as 0. So it means that you can start with anything. So there is no restriction in the starting point. That can be 0 plus 1 star. And remember, when you mean the fourth symbol from the left, from the right as a 0, you should see 3 symbols towards the end, which can be anything. Okay, so you can have a 0 plus 1, 0 plus 1, 0 plus 1. So these are the, these are the last 3 symbols. 3 symbols. And these are, these are in the right also. Okay, now the fourth symbol from the right is going to occupy this space. Okay, so this space has to be filled with a 0. That's mandatory. So here you have to show with a 0. Again, this can be again simplified and can be written as 0 plus 1 star followed by a 0 and then 0 plus 1 3 times. Okay, so this is going to be the regular expression for having to represent the language where the fourth symbol from the right is a 0. Now let's go to the next question. So here we want to see to it that the strings contain exactly 2 zeros. Exactly 2 zeros. Okay, so the minimum string that has to be accepted is going to be a 0 0. Okay. So again, you can accept a string like 0 1 0. This is possible. You can accept 0 1 1 0. This is possible. So but you cannot accept something like 0 1 0 0 because this contains 3 zeros, right? So this has all these 3 can be accepted, whereas this cannot be accepted. Okay, so let's start designing it. So I should see a 0 0. That's the only condition there. So in between, I can have anything. Okay, so that means you can even begin with a 0 or a 1. Okay, so I can write it like this. See, if I write it like this, 1 star. Okay, then followed by 0. Again, I'm putting a 1 star because I can have ones in between also. Okay, again I can see a 0, again followed by a 1 star. Okay, this is the way I'm designing it. Okay, let's look at what happens to 0 0. So if star means 0, that means this is going to be empty, and this is also going to be empty, and this is also good. So in that sense, 0 0 will be accepted. What about 0 1 0? So if 0 1 0 is the case, so this star is going to represent there will be nothing here. So this would mean one repetition. So you'll get a 0 and a 1, and then this would mean 0 repetition. So this won't be there. So you'll be getting accepted as 0 1 0. Okay. Similarly, you can check for all these strings and then verify that there can be a way of representing this language by this regular expression. So the regular expression is 1 star 0, again 1 star, again a 0, again 1 star. Okay, so by looking at this regular expression, okay, you can verify that all the strings that contains exactly 2 zeros can be represented by using this regular expression. Okay, in this question, we have to solve for strings that contain at least 2 zeros. At least 2 zeros. Okay, so it means that you can see anything in the beginning 0, 1, 0 plus 1 star. Okay, so for satisfying at least 2 zeros, I can do it like this. I can write a 0 here, followed by again 0 plus 1 star, followed by 0, again 0 plus 1 star. You can verify that this particular regular expression will be able to cover all the strings which contain at least 2 zeros. Okay, so let's look at the next question. So the next question is just a variation from this question. Strings containing at most 2 zeros. So this is going to be slightly tricky. At most 2 zeros. Okay, so here the term is at most. So we can have 0 zeros. So the possibilities here are we can have no zeros at all. So no zeros is possible. Just 1 zero is possible. 2 zeros possible. 2 zeros is also possible. So these are the 3 cases which we need to take care of, right? Now let's start designing this. Now I can say that for the first case, there is no zeros at all. I can say it as 1 star. 1 star would represent all the strings without any zeros. Now what about 1 0? 1 0 can be represented just 1 0. Okay, so it can be represented by 1 star 0 again followed by 1 star. This would represent all the strings containing just 1 0 in it. What about 2 zeros? So exactly 2 zeros. So we have already seen this. This is going to be 1 star 0, 1 star, again 0, and again 1 star. What if I combine all this? I'm just saying plus here and plus here. Okay, so this part will accept no zeros, no zeros. This part will accept all the strings with 1 0, and this part will accept all the cases with 2 zeros. Right. Now all the cases are getting fitting in, are getting accepted, right? So this is one way of designing it. Again, we can have a shorter version of this. Okay, if you look at this carefully, we can make it much simpler. Okay, so here, if you look at here in this expression, which accepts 2 zeros, okay, exactly 2 zeros, we can add an epsilon to this 0. So instead of saying 0 here, I can say it as 0 plus epsilon, 0 plus epsilon. Similarly, this can also be done here. So instead of saying a 0 here, I can say 0 plus epsilon. So if I say like that, then it would have a different meaning. So let me write it separately here and then explain it. So if I write it like this, 1 star followed by 0 plus epsilon, followed by again 1 star, followed by 0 plus epsilon, and again followed by 1 star. And what's the meaning of this one? 0 plus epsilon. This means that either you can put a 0 there or an empty string. Okay. So if you're putting an empty string, it would mean that you're putting no zeros there. Similarly, here also you have a choice. You can either use a 0 there or an empty string. Okay, so suppose if you are using an empty string instead of 0 in both these locations. So this is going to be your location 1 and this is going to be location 2. And if you're using epsilon in both those locations, what you're essentially getting is 1 star is going to be let me take the pen. Okay, it's going to be 1 star. So you have an empty string, again 1 star and 1 star. Okay, so this is equivalent to no zeros at all. Okay, now let's look at the second case where we need to exactly, accept strings with just 1 0. Okay, so in that particular case, I will say in location 1 or in location 2, I have a choice of, just taking epsilon. Okay, so that means it can be that there are two ways of having this. It can be 1 star. So if in location 1 I am going to represent that 0, it is going to be 1 star, then 0 and 1 star. So this is one way. Okay. Similarly, this also represent this one, 1 star, 0, 1 star, 1 star. This also represents the strings which can accept, which contains just 1 0. Okay, now in location 1 and location 2, I am accepting zeros. Okay, so the equivalent expressions will become 1 star, 0, 1 star, 0 and 1 star. So if you look at all these cases, it covers everything from no zeros, 1 0 and 2 zeros. And that's what we want. We want at most 2 zeros. So the number of zeros cannot be more than 2. It can be 0. The number of zeros can be 0, 1 or 2. Okay, so since we have covered all these cases in this regular expression, and this is going to be our regular expression for, for representing strings that contains at most 2 zeros. So this can be easily derived from the strings that contain exactly 2 zeros. So this was the this was the string that we have. This was the regular expression that we have constructed for accepting strings containing exactly 2 zeros. So instead of a 0 there, you can replace it with a 0 plus epsilon. You can replace that the 0 plus epsilon in both the locations, so that the regular expression gets converted to the strings, for representing strings containing at most 2 zeros. Now let us look at a few more questions which deals with the word length of a given string. So the first question is very easy. The word length has to be exactly equal to 2. So that's what's mentioned here. So for that we can have any pattern 0 or a 1, right? Followed by again any pattern 0 or a 1. Okay, so this is going to be the the representation of strings with exactly the word length as 2. So you can either see a 0 or 1 followed by either a 0 or 1. That's all. Now, what about the word length greater than or equal to 2? Let's look into it. Now here we should guarantee that there is at least two symbols in your string. So you can write it like this. So once you write 0 plus 1 followed by 0 plus 1, okay, so there will be two strings, two symbols in your string. Okay, that's guaranteed. From here, you can see anything. Okay, so the condition is that it should be greater than or equal to 2. The minimum should be 2. So that's why we are saying 0 plus 1, 0 plus 1, again followed by 0 plus 1. This can repeat 0 or more times. So that's why in the last 0 or 1 combination, we can put a star there. So this means that this particular pattern can repeat 0 or more times. So that's it. So that would represent all the strings whose word length is greater than or equal to 2. Now, the next question is about the word length less than or equal to. This is slightly more tricky. Okay, let's see how we can solve this. Okay, remember that when we say less than or equal to 2, the word length can be 0, 1 or 2. Okay, maximum it can be 2. Okay, so how can we represent this? So we can actually, if we are writing 0 plus 1, okay, 0 plus 1 followed by 0 plus 1, this would mean that this string is going to have exactly the word length as 2. So we don't want this. We want the size to be 0, 1 or 2. Any of this is possible to be accepted. So The only small modification we can do here is that we can add an epsilon as well here. 0 plus 1 or an epsilon here also. Okay, so if you put an epsilon here, okay, so that means you have the choice of either selecting a 0, 1 or an epsilon. Okay, so if you select epsilons in both cases, in both these locations, then your string length will be 0. If you select one of them as an epsilon, then your string length will be 1. And if you select none of them as epsilons, then your string length will be 2. Right. So this is how we can manage to construct a regular expression for where word length is expected to be less than or equal to 2. Now, one more question, which is again based on modulo arithmetic notations. Here we want to make sure that the word length is congruent to 0 mod 2. Okay, so this means that upon dividing the word length by 2, you should get a remainder of 0. That essentially means that the word length has to be even. Now, if I'm writing that like this 0 plus 1, 0 plus 1. Okay, so this would mean that the string's word length is exactly 2. So I want the multiples of 2. So I can actually combine this and then say a star here. So this would mean 0 or more occurrence of the string that is inside the bracket. So that would essentially confirm that the string's word length is going to be a multiple of 2, right? So based on the value of the star that you're giving, so if the star, if you are meaning a 0, then your string length will be 0. If you're putting a 1 for your star, then your string length will be 2. If you're putting 2 for your star, then your string length is going to be 4, and so on. So this can be verified, and this can be expressed in a crisper manner by just saying 0 plus 1 2 times star of that. Okay, so this is a shorter version of the same expression. Okay. Now, as an assignment, you can try the following questions. So the first question is that strings that starts with 0 and the string length is even. Okay, so the condition here is string length is even and starts with 0. So the second question, string length has to be congruent to 2 mod 3. So we have already seen a question where we solved where the string length is 0 mod 2. Okay, that's nothing but even. And then we have the last question, the third question, strings containing exactly 2 consecutive zeros. So here the word consecutive is very important. So we have actually showed how to solve strings, how to solve for strings containing exactly 2 zeros. So here it is slightly different. It is strings containing exactly but 2 consecutive zeros. What we wanted is 2 zeros which are consecutive. Okay,